ever launched a water rocket as a kid?
Oh, yeah.
You know, that feeling, you get that like, whoosh!
Yeah,
Toys blasting off, right?
totally.
Well, we're taking a little trip down memory lane today, but with a twist.
Okay.
We're diving into the world of Hsin-Luen Tsai and their incredible water rocket experiments on YouTube.
Oh, cool.
Have you seen any of these videos?
I have. They're very impressive.
They're amazing, right?
Yeah.
So for those who haven't, Hsin-Luen Tsai, they document like all these experiments. And you know what's amazing about it?
What's that?
It's not just about launching these rockets. It's about predicting exactly where they'll land.
Yeah, that's the thing that always gets me. It's like, it's one thing to like build a water rocket and launch it in the air, but to be able to say, okay, it's going to land right over there.
Exactly.
That's some next level stuff.
Pinpoint accuracy.
Pinpoint accuracy.
Yeah. All right, so let's unpack this a little bit. Hsin-Luen Tsai walks us through every step.
Right.
They're measuring the water, they're carefully pressurizing the rocket, they're even factoring in things like the wind.
Yeah, which is huge.
Yeah.
I mean, wind can really throw off your whole trajectory.
And it's not just point and launch, is it?
No. There's a lot more to it. I mean, it's a real science, right?
Right.
Like, what fascinates me is the methodical approach that Hsin-Luen Tsai takes. Like, they're treating this like a real scientific investigation.
Yeah.
And that's key for reproducibility, too.
Yeah.
Because they're controlling each variable. They're documenting everything carefully. So you know that if someone wanted to replicate these experiments, they could.
Exactly. And the results are, I mean, wow.
Pretty impressive.
Yeah. I mean, in a 2022 video that I was watching, they achieve a range of almost 60 meters.
That's incredible.
That's like launching something the length of a basketball court.
That's wild. Yeah.
So how are they getting that kind of distance? How do they do it?
Well, like we were saying, it's all about understanding the physics involved.
Oh, right.
So, like, take filling factor, for example.
Oh.
So that's basically the ratio of water to the total volume of the rocket. And in that particular launch, they use 25.9%.
Okay.
Which is pretty specific, right?
Yeah.
And then you've got the initial pressure, which was 5.5 atmospheres.
Wow.
Yeah. And then, of course, the launch angle.
Yeah.
That was a precise 55 degrees. And each of these factors plays a crucial role in determining how far that rocket's going to travel.
It's amazing. So it's not just about building a powerful rocket, right? It's about understanding all these subtle nuances and using them to your advantage. Like, that's how you achieve this incredible accuracy.
Totally. It's like fine-tuning a race car.
Yeah.
You know, to get the best performance.
Yeah. It's like they cracked the code or something.
Exactly.
And speaking of codes, this brings us to, like, the world of physics. Like, how cool is this? We're talking about water rockets.
Yeah, but it's real science, right?
Yeah.
And that accuracy that Hsin-Luen Tsai is able to get just highlights the power of understanding the science at play.
Yeah.
So, you know, we're talking about things like projectile motion.
Right.
You think about the curved path a basketball takes when you shoot a hoop.
Right.
Air resistance, wind drift, all of that comes into play. And by factoring in all of those elements, we can predict where these rockets are going to land with this incredible, surprising, frankly, precision.
Yeah, it's really incredible. But, you know, while those results are super impressive, they also kind of highlight how unpredictable things can be.
Oh, absolutely.
Like, I was remembering that 2021 video where the wind caused a little bit of, you know...
Oh, yeah, that did not go as planned.
No.
Yeah,
but it was a perfect example of, you know, how even, like, a slight variation in conditions...
Right, have a huge impact.
It can totally throw things off.
Yeah.
And it makes this accurate prediction stuff all the more impressive.
Totally.
Yeah. Because, you know, you get a sudden gust of wind, that's going to throw off the trajectory of your rocket. And it, you know... I don't know, it reminds us that real-world scenarios are just complex.
Oh, absolutely.
You can't control for everything.
No, you can't. And it makes you realize, too, that even small factors matter. Like, you might think, oh, it's just a little bit of wind. But no, it can make a huge difference.
It's true.
Yeah.
It's true. I mean, just imagine trying to account for all those variables, right? It's like you're solving a constantly changing puzzle.
Yes.
Have you ever tried, like, something that seems really simple and it's totally unpredictable? I'm thinking like throwing a paper airplane.
Yeah.
It's like the slightest breeze will just take it off course.
Absolutely.
And it just, I don't know, it just shows you that even something as simple as that involves a surprising amount of, you know, science.
Totally. And it's a good reminder that these principles, this experimentation and analysis, like, you could apply that to all sorts of things in your life.
Exactly. Not just water rockets.
not just water rockets.
So what does this all mean for you? What other everyday activities could benefit from this kind of analysis?
That's a good question.
Right. Could you build a water rocket and predict its landing spot? Maybe even become the next Hsin-Luen Tsai? Something to think about.
Definitely something to think about.